All right. So what we're trying to do is we are giving a Docker container-based command line for Cloud Mesh. That was the idea. So I'll just showcase you how it all works and probably um,
So
the internals of it.
so let me just put this in perspective. I come over here. So why are we doing this? So this is a cloud class, and a cloud class has virtual machines, but cloud also uses containers. We will be introducing you at the later half the difference between containers and virtual machines, but we want to start you with some activities so that you have already the ability to use certain things. The reason why we do this is because we see some of the students not doing the exercises that we have assigned, such as, for example, configuring Cloud Mesh on Windows. And we saw, for example, over the last week, that when errors are being posted by the operating system, such as Visual C++ compiler needs to be installed, students don't install Visual C++ compiler, and then they say Cloud Mesh doesn't work. You know, if you don't provide us with a computer on which you can actually do the development, you should not be surprised that Cloud Mesh cannot work on that particular machine, because this is a development effort. We're doing cloud engineering. We are not using cloud. We are not cloud users. We are cloud engineers and not cloud users. And that's really important. And so what we came up with is instead of you know, having people not upgrading machines while not installing Visual C++, which happened all over the week like now to multiple people, despite the fact that it's clearly said, please install it. We came on the idea, why don't we just release some material that we would have normally released in the second half of this class, but is immediately useful for those who do not want to read the documentation or the warnings from your operating system. So Miranda will be now displaying to you how do you install Cloud Mesh in a container and run it from within these containers. And not only that, we wrapped this command into a Cloud Mesh installer, just as we have already introduced you with multipass. So you're familiar with that concept, but we are now using a different thing that's called CMSD. And so Niranda will go now on.
Right. So yeah, like Gregor said, so this is basically like a bypass to CMS. All right, so you guys will learn about Docker and containers later on, but simply put, Docker is like a VM which is running inside your machine itself. So what we are doing here is we are running two Docker containers. One is for the Cloud Mesh and the other one is for the MongoDB. And right, so let me first log into my workstation. Right, so I have this is where my Cloud Mesh is usually. Right, so first and foremost, what you would need to do is, like, I'm pretty sure you guys might have used Cloud Mesh installer. So I need to use Cloud Mesh installer. So for me to do that, I first need to activate my environment. So in this, I have my Cloud Mesh installer. Let's install that. That'll be easier. Install my Cloud Mesh. Right. So I have Cloud Mesh installer now. You can see that. Can see Cloud Mesh installer. That's working. Right. That's the first part. And then I'm going to use Cloud Mesh installer to install the Cloud Mesh Docker containers. Docker, basically the CLI, it's called CMSD. So it will be Cloud Mesh install CMSD. So what this would do is this would basically pull up this Cloud Mesh CMSD repo and install it locally. So
So one more interruption. In case you want to do this, you must have already Docker installed
yeah,
on your machine. So you cannot do this if you have not Docker installed.
right. So, oh, and one more small warning. I've only tested it yet on Unix. I'm still yet to test it on Windows because there could be some issues with the path separators and stuff. So just a warning. But yeah, let's get on with it. So right. So once we've installed CMSD, let's just check whether it's there. CMSD dash dash. This is quite important. You need to use dash dash in CMSD. So right. Give you a small clarification. Now in CMSD, in CMS specifically, there are, all right. In CMS, there is a thing called CMS help. That's also there. And CMS, so basically when you learn CMS, you'll see CMS has CMS help and all of that. So what we're trying to do is to give like an interface to the CMS through another shell. So here the CMSD shell would have another set of commands, but all of it would be uh, prepended by two dashes. Whereas if you provide a command without any dash, that would go through to the container which runs CMS. So that's how we bypass it. Whatever you use dash dash would be to the CMSD CLI, whereas if you don't provide any dash dash or whatever, it goes to the CMS CLI, which is inside the container. All right. So, um, right. So CMS D dash dash help would tell me whether CMSD is up and running or not, whether it's there or not. So now let's see whether CMSD has a another command called PS that would tell you whether there are any Docker containers running. So this is very similar to Docker. This is basically the same as Docker PS. That will tell you whether there are containers up and running or not. So now, when I did Cloud Mesh installer install CMSD, what it has done is it has installed this Cloud Mesh CMSD. You would only have this Cloud Mesh CMSD on your machine, and that would have copied the entire repo into this particular directory which you are in. I'm in my CM directory. So it has copied the repo into my CM directory. And now, this is what I'm going to do. I'm going to create a temporary directory so that I could use it as a mount point to the Docker container. That mount point would serve as the Cloud Mesh home directory. That is what's referenced here, Cloud Mesh home directory. And so what I'm do is I'm going to mount this particular directory. Let's see whether there is anything in this first of all. Oh, there are. So let me remove all of these stuff. I might need sudo. I'll tell you why I need sudo later on. All right, so I'm going to create a temporary directory, temp1, so that this directory would be mounted into the CMS as the Cloud Mesh home. So this is done internally through CMSD. And so what you need to do is you need to create a temporary directory and call CMSD setup dash dash that particular directory. So then Cloud Mesh container would take this temp1 as the Cloud Mesh home and mount it into the CMS container. Right, so once this is done internally inside CMS, it runs the CMS help so that it would populate the CMS, the Cloud Mesh YAML file, which does all the configuration for Cloud Mesh basically. So you can check that. So now let's see whether this is up and running. It's simply saying cmsd --ps. Now you could see Cloud Mesh CMS is running. Ideally, there should be another MongoDB container also running here. But it's not running because we just initialized the Cloud Mesh config file. So we need to set, that's where this warning comes up. It says, please set Mongo password in the Cloud Mesh YAML file and rerun setup. So we need to do that. We can do it in several ways. The easiest would be, now, okay, let me just verify the mount point as well. If you check the temp one, which I used as the mount point, now you could see the Cloud Mesh YAML is there. There are a couple more like housekeeping files that have been created. Just to show cat temp one Cloud Mesh YAML. So this is basically the YAML file. And as you can see here, the Mongo password is set to TBD. So we need to change that.
Remember, this is recorded, and if you have passwords, then there would be no recording.
Right, that's fine. So next up, so we need to set that password. There are a couple of ways you can do it. You can physically go to that file and change it. That's possible. I'm going to use a Cloud Mesh tool to do that. So I'm going to use this thing called cmsd set command, config set command, or whatever there. So I'm going to do cmsd config set and this. All right, let's see what happens. Okay, so
Let me just explain what this is a little bit. So you see here we have cmsd config. We have a configuration file in Cloud Mesh. The config command interfaces with the configuration file. And the set command essentially says this is set a variable in the configuration file. The configuration file stores everything as YAML file. It's essentially a tree of dicts, if you so want. Then we have a dot notation in YAML that we have used because Cloud Mesh is the first entry. Then under Cloud Mesh, we have data. Under data, we have Mongo. Under Mongo, we have Mongo password. And then we set this admin 123. So this way, in this notation, we can very easily set in our YAML file that contains all the configurations for this. And so that's what Niranda is doing.
So if we want to cat the config, we can do config cat. That would print out the entire the Cloud Mesh configuration, and here it's been dashed out, but we know that this has been set now. Just to verify, I can do another.
Don't verify.
Do the get.
The command that we just did with the config cat has been explicitly developed for this class because the students always expose their Amazon and Azure accounts, and we are recording our meetings. We don't want that you actually show us your YAML file. What we want you to use is we want you to use the config cat command. And if you do actually help on the config command, you see there's another option there. The option is less. So if you,
less.
for example, say config cat less, it will scroll you through your file. Well, apparently not apparently here. So there are some bugs in here. So we
you can actually do like value or something.
Yeah.
But that's fine.
That's fine. So we have to work on that one.
This, let me just verify from here. So this would be my cloud mesh, the actual YAML file which has been mounted. So if you go here, the admin 123 has
Actually,
been set.
because you are running this, through a shell. I know why this is wrong. So can you just do again CMS config cat and then pipe less? In this particular case, we can use a pipe.
I don't think, because I'm going through.
So now you can use the return to scroll through. So this way you have.
All right. So now the MongoDB has set up. Now if we do docker ps or cloud cmsd -ps, I'm still only running the CMS. So I need to run the setup again to start off the MongoDB container. So now, the container is already running, so it wouldn't do anything there. And it will start up the Mongo container. Now, if you go and do docker ps, you can see the Mongo container running.
Yeah. What is that setup command? What is that doing?
So what that setup command does is it would look at the, if you know a bit about containers, for a container to run, you need to have this thing called an image. So what the setup does is it takes up the Cloud Mesh image. If it's not there, it will build the image using a Docker file. And then it will first start up the Cloud Mesh container and then moves on to use the MongoDB container from this thing called Docker Hub, where you can download like official Docker images. So I'm using the MongoDB 4.2 Ubuntu, no, not Ubuntu, Debian, I think Buster image for this. And yeah, and the Cloud Mesh is built using, you can see that here actually. If I go to here, CMSD, CMSD.
And all of this should be familiar to you now because we have already gone through the CMS sys command generate, because this is exactly what we used. And then we just filled out the manual page, and then we developed the content for it.
Yeah, so here you can, once you guys learn about containers, you'll know what these actually mean. So what I'm using is a Python 3.7 Buster image for the Cloud Mesh. And inside this, I'm using MongoDB 4.2. That is again another Debian Buster image that MongoDB provides. So those are like the two images. So coming back.
So these images are not a part of Cloud Mesh or CMSD, right?
So what happens is you can think of an image like an OS ISO file. So what the container basically does is it takes the image and basically like unzip it and create like a virtual machine. That's like the simplest way of doing it, simplest way of putting it. If you like, do I want to explain it more? So,
no, don't explain more.
Okay.
Just explain the usage, because
Okay.
we have an entire class dedicated to
Right.
to how
Okay.
this works.
Yeah. So
we
then,
will do this.
because once you have an image, you can spawn multiple containers from the same image, and it's very simple. It's just a single command to do that. All right. So again, docker ps. So I have the two containers up and running. Let me see what we have to do next. All right. Okay. So, so at this point, if you do CMSD help, like I said earlier, this would pipe to the CMS cloud mesh help that would print out what a usual cloud mesh help would do. If you want to do something like config help is there, right?
Yeah. It should be help config
Okay.
the other way around. Oh, okay.
Yeah.
Good.
Okay. So likewise, it pipes through to the container and runs it. So for you guys to just show some functionality, I'm going to use AWS. I have an AWS account set up, and there is documentation about how to set up AWS and all that. You'll come across it later on. But to do that, I'm going to just copy a file which already has that commands inside.
So why did he do the copy process? He has pre-configured Amazon Web Services configuration in there. And so naturally, he doesn't want to show that to you. So he wanted to be making sure that this is in a secure location. And he just copied this over so that he can authenticate against Amazon.
Yeah, basically that's what I'm doing. So if I can, all right. So one more thing I want to show you guys now. I told you now we have Docker PS. So we have these containers running. If you want to access the CMS container, you can use CMSD shell. That would take you to the CMS container. So now basically I'm inside the CMS container basically. So if you go, you can, the CMS config would be in here, cd, sorry, less dot cloud mesh, YAML. Oh, less is not there.
Less. Do just an ls.
Yeah. So
it's, have your credentials in there.
Yeah, it's so basically I'm now running inside the VM. I'm just going to exit the container. If you want to inspect inside what's going on, you can do that if you want to. Just
so the minus shell means he's just starting a computer in the container basically, or a shell in the container. So if you, for example, have a Windows machine, he pointed out he installed a particular Unix container that contains Python. And that's what this thing does. Yeah. Without no effort, if you were to have Docker running on your Windows machine, you don't have to install Cloud Mesh anymore, Cloud Mesh Multipass. So what he has actually done is he has created a container that contains Cloud Mesh, in which you can now install Cloud Mesh Multipass. However, but Multipass, you can't access your operating system because we are here in a container. But what he is doing now is he is trying to access a different cloud, Amazon or Azure, which is completely outside of your container, and Cloud Mesh can interface with them through the APIs that we are accessing from within Cloud Mesh. So without no effort, he hasn't actually installed a lot of stuff. He lets the container do the work, and then installs in the container Cloud Mesh, which we have done in this particular CMSD automatically for you. And the setup that he has called configures Cloud Mesh for you in that container. And when he said Cloud Mesh minus shells, he logs into that container, which you can think about as this is just another computer for you. And from that you can install other things for this class in there. Only thing you can't do is GUIs.
Yeah, you can't do it.
But because he mounted the file system, what you can do is you can use your native Windows GUI to go to the same file system, make the modifications, then click on the shell and run all the commands that you have in that shell available on that file system, such as, for example, Python commands because he has a Python compiler. So technically, it's now possible for you not to even install Python on your Windows machine or your Linux machine or your other machine because you have it already in that image. Only thing you need to have is Docker running on your machine. And that's the reason why we have spent such a great effort on upgrading your computers from Windows 10 Home to Windows 10 Education or Pro, because you cannot run containers on Windows 10 Home. It's impossible to do that. Windows does not provide a proper operating system to home users.
Right. Yeah. So basically, in an event where you want to upgrade Python or all of that, you just need to change that container image to Python 3.8 if you need. Gregor wanted to use Python 3.8, you just have to change that Docker file later on. So that's like the simplest way of doing it. And there are other things also you can do using Docker Hub and all of that. We'll come to it later on in the container sections. Right, so coming back now, I'm going to use the cloud AWS. So for that, I'm going to do CMSD. You would come across these stuff later on, but so I want to use the AWS cloud. So I'm going to set it as AWS. And then inside my AWS, I have actually uploaded a particular key pair. And that key pair has this Niranda in it. So I need to reference that name to associate with CMS. So for that, I need this part. This is like an internal for AWS. These things changed between the implementations. And then I just need to do VM boot. CMSD VM boot would essentially create this would actually create a VM inside through AWS.
So can you put once more up this window?
This one?
Yeah, this one. So as you see here from the commands, starting from line number 17 to line number 20, he interacts now with the virtual machine that he starts on AWS. Remember that we did this with multipass. In multipass, what we did actually is we started a virtual machine through multipass, and you could see it via the list command that you actually started things. Now, the list command is different because it's list on multipass. It may be called VMs on another cloud. It may be called something else on another cloud. So no one can remember any of these commands because they're all different. However, in principle, what we really want on the high level is we want to have a virtual machine. So why not call it VM boot, right? Because this is what we want to do. So this is where Cloud Mesh comes in place. We essentially say, this is, okay, boot me a virtual machine. Where should we boot this on? Oh, we should be booting this on Amazon. What would we have to do to boot it on multipass if we were to develop our multipass? Okay, CMSD set cloud equal to multipass. And then what we should be doing is a CMSD boot to boot a virtual machine on multipass. It's the only difference that we actually do. Now, there's a little bit more trickery to this because we have a configuration file that tells you what the flavor is of the operating system, essentially what the size is, what the operating system is that we actually start, the default operating system. And so all of this stuff we can sometimes actually hide. And so what I found is with many students, they're not even interested in anymore figuring out what operating the system they start, especially those coming from the data science program. What they want to just say is start me a virtual machine, no, regardless of what, I don't really care. And that's what we do. We provide them with a default so that they don't actually have to care anymore. This kind of stuff, if you were to do this just from the command line, is typically out of scope for the data science students, as we found out. that we found out the hardware, because they have never really seen a command line. They only have seen a GUI. They can only start Jupyter notebooks. They cannot do any of this stuff. So what we are doing now is provide them with a simple interface so that they can even do this on the command line with 3 commands. So as you can see, we have 20 commands to start a virtual machine on Amazon. Isn't that cool? That's just super cool, you know. We don't have to develop a program for this. We just have already such a program. However, this is the cloud engineering class where we teach you how to design such a program that is so super cool that even your grandmother can start a virtual machine on Amazon. Right? And I don't want to actually put you know, your grandmother down. Your grandmother may be more smarter than me, right? Just as my mother is smarter than me, I could teach this to my mother. She has not a degree in computer science or anything, but she is so curious in doing these kind of things. I can teach it to her even without a computer science degree. I can go to an elementary school kid and teach this to an elementary school kid, and they will be doing this. I often say, hey, I have taught certain things to elementary school kids. I test this actually out on them, and they can do this stuff. So you should not be, you know, and these are the students that you may actually have to compete with in your job market when they come and graduate from high school, right? Not only you with your university degree have knowledge, but also those who actually have already a high school degree. I don't discriminate against anybody. They may already know how to set up data science and Jupyter notebooks. So Jupyter notebooks, using Jupyter notebooks is done on a high school level. It's not done on any university level anymore. So this is here still university stuff, because when we develop this, that's typically beyond the scope of some of the students that you have. And this is where how you can distinguish yourselves when you go in the job application. You know, I have not only started a Jupyter notebook, but I know also how to interface with these classes. So the boot, naturally, we want to shut the thing down, because everything, you know, if you run this thing for 100 hours, you know, you get charged for it. Even though you have the free tier, you know, you can only run that many virtual machines. So Niranda will show you now the terminate program.
Yeah, that's the case in.
Or maybe you can just show once more the GUI interface from here. So here's yeah, just show this one here on the bottom. So this is actually our JSON object coming back from the cloud that we put into the MongoDB. And so the people that are doing the JavaScript stuff have all the information that actually is associated with the virtual machine to do cool renderings of this thing. So for example, say, okay, you know, is there, for example, what's the architecture of this image? So we can actually look at this. What would be maybe here the network interface ID? So we have the network interface ID being published. So there's a lot of information coming in that typically is not necessary for any data science students, because they said, oh, boot me a virtual machine, right? But we as engineers may be interested in much more detailed views that are not be suitable for other students to understand. And so you as an engineer have access to everything which is actually stored in our virtual machine. Not only that, this is, I think, can you look for the CM? Do you have here already the CM directory added to it?
Yeah.
If you can locate this. The most important part for Cloud Mesh, so that we can figure out, because we are getting objects from all kinds of clouds, we now need to be figuring out, is an object coming from Amazon, or is an object coming from OpenStack or Multipass? We have added a dictionary to it. This dictionary is called CM. And as you can see, it has an attribute, cloud. The attribute cloud would be AWS. It includes a creation date. When is the thing created? It has a driver in it. The driver is our own Cloud Mesh driver. And we have a name associated with that driver. And in this particular case, it's the string AWS. We have a kind, because we have images, we have virtual machines, we may have containers, we may have other things. And so in this case, we have actually a virtual machine that we started. We have a name, and the name is automatically generated. As you see, when we said CMS VM boot, we didn't specify a name. How do we log into our image? With CMS VM SSH. It takes the last name that we actually have, and we can list all the virtual machines that we have defined and put some in there. And then there's an updated information in there. In OpenStack, so we have not yet here in this particular case added how much time it takes to start up the virtual machine, but we have that information also in OpenStack. And it will be showing up at one point. We just have to double check if this is also used in AWS. But in OpenStack, it, for example, says this is, you needed 37 seconds to start up a virtual machine, right? So this way, when we do benchmarks with your wonderful work at later point, we can look at information such as this and figure out, how long does it actually take for you to start a virtual machine? If you are in a different region, because as you know from the data center, there are tens of data centers in Amazon. If you start a virtual machine in Asia, how do you know that this takes the same amount of time than if you were starting a virtual machine in California? And actually, we may see differences based on how busy these data centers are. And we may have to find data centers on which the startup time is small, depending on what you have. So now let's go take a look based on the GUI that Niranda has. And so he has here, as you saw, we had a virtual machine called VM2. We have the instance ID, we know medium, all this information is taken from the Cloud Mesh YAML file, so we don't have to look into this. These are default values that we give. But you can see we can also look into the GUI. We could be starting and stopping this also in the GUI. And then now you may ask, why would I want to even use anything else but the GUI? You as data science students that may need one virtual machine, you may not want to use anything but the GUI. But what if you want to start 10,000 virtual machines? That's not an unheard. We have done that. So why not start 10,000 machines? Why would you want to have 10,000 machines? To do, for example, physics calculation, to do calculations to verify if the God quark exists or some other thing. This takes tens of thousands of computing hours, right? So this is not as simple as Twitter data analysis. This is trivial. There are other problems out there that are much more complicated that require this intense amount of work. Now, I don't think it would be a good idea to manage 10,000 virtual machines via GUI. You're browsing till Christmas time on 10,000 virtual machines. You somehow need to be having a different interface. Now, in our list function, we can specify the names and we can specify ranges and we can list a particular information. We can develop services that are just specifically targeted towards list me all virtual machines that failed. List me all virtual machines that are in this particular state. List me all virtual machines that have maybe a file and a particular location in it. That are all programming tasks that you may need to be doing. And so Cloud Mesh will be able to help you with this kind of a task. And also teaches you mostly the concepts that are needed in order to do this. So that's the reason why we typically don't use the GUI. Now, in addition, there is actually a Cloud Mesh AWS registry, or a Cloud Mesh register AWS, where you don't even have to go necessarily to click through all the account creation in AWS. Cloud Mesh walks you through the account creation while popping up in the browser the necessary windows, and you just have to fill it out. So that's also possible, and one student actually did this as a side project when we did registration. So, but there's nothing wrong with the GUI as long as you find it scalable. However, in our class, we do everything from the command line because we want to teach you the concepts of how do you do something like this from the command line. Now we have a project that's called Cloud Mesh JavaScript GUI, where we try to develop a GUI that looks similar to this, but not for AWS, but for any arbitrary cloud that we actually have. So we want to not only list the instances for AWS, but from Azure, Google, OpenStack, Multipass, Kubernetes, Docker, and they should all be showing up here in a GUI. And so naturally the types here, as you saw, we saw that big gigantic JSON object, they're completely different between one cloud and the other. So in Azure, we may not have instance type. So now the question for those people becomes, this is what should we display? So we have to probably create some tables that map attributes from one attribute to a generalized table view. The other thing is for each one of the clouds, we have our own table view, and we want to showcase those. Now, Niranda, why don't you pop up your pie chart?
I don't have anything here.
Go to the web browser and go to the OpenStack. Go to the cloud, to the go to Cloud Mesh and then Cloud Mesh-multipass. So we were trying to teach you through multipass because it's the most simplest JSON object that we can actually imagine. If you go in multipass to Cloud Mesh, you know, you go to multipass. You know that we have in command, you don't have to go to command, we have the command and command, but we have a provider that we interface with multipass, and that is what you need to be developing. So, and also integrate this provider into command. So if you go to provider, you have at the top of this provider a string called output. And that, remember when we want to display maybe in a table form the virtual machines, we write down here what are the fields in the JSON object. What should we use as headline? Now in the JavaScript thing, we take this information and instead of creating the table that we actually have, we create JavaScript objects. So now, what are we doing further down? So go a little bit further down. We actually have a print object here, which is more or less render an HTML page in JavaScript. But instead of rendering an HTML page, we just print out the table in ASCII format. And so if you look at this, it converts a JSON object to what we call the flat dict. That's a pretty good invention that we came up with at one point because we had at one point a NoSQL database and we needed to push it into a NoSQL database, but it takes the attribute names of the hierarchical JSON object and flattens them out. And whenever we get a new hierarchy, it puts a dot in between. So this way we can say, you know, CMS.name. You saw before the CMS object. So now what we simply do is we print an object of a particular kind. We spend the kind. We look for the kind here, see, self.output of kind of order and self.output of kind header, which we have order and header. We just pass them along into the flat write operation, and the output specifies the output format. That is either CSV, table, YAML, something else. We could as well add to this printer an HTML output, and then an HTML table would be printed. We can just as easily modify that. And then this could be reused, for example, in developing HTML pages. I'm not sure how to integrate that yet in JavaScript, but you know that's one of the things that we could do. And it would just print out whatever we want in HTML, and then we just use that table. So there are other things such as humanize. There's actually a bug in Cloud Mesh at this time. We print out all the times wrong. If you see it, this is okay, this virtual machine has started 4 hours in the future. So we don't have yet the rendering correctly done for GMT time mapping and those kind of things. So don't worry about that. But that is something that you guys can take a look into at one point. And maybe we put here a different library. Humanize is a library developed by someone else. Maybe we find a better library that does this easier. So this is how we actually do this. And when you go further down here in the in this thing, there's an update dict. Remember we had the CM directory in the JSON object for AWS. We also have a CM directory in the multipass, and the update dict integrates into the multipass in CM directory with the attributes kind, driver, cloud, and name. And that's what you do here. And each provider has an update dict. Whenever you return an object from a provider, the object is supposed to be a dictionary that is being augmented with this CM entry. And when that CM entry is there, and you integrate this in the rest of Cloud Mesh, that's now the beauty of the whole Cloud Mesh thing. It automatically integrates this object into the database without you to do anything. So, and this is the reason why this is so cool and why we actually can do this in class, because the only thing you have to do is in order to go out to a cloud to start a virtual machine and how to do this, you have to learn how do you do the API for starting a virtual machine. Then you have to define all the methods that we are using. There is an abstract base class that we have defined. You need to be defining those, and once they're defined, Gregor will be integrating this particular provider in Cloud Mesh so that we can say, after the CMS Cloud Mesh installer install multipass in this particular case, it will be automatically integrated into the namespace of Cloud Mesh, and you will be able to get CMS VM boot for multipass. And so this, thousands and thousands of lines of code you don't actually have to develop. You just have to make sure that this provider is being created. And once this provider is being created, we can easily integrate it into Cloud Mesh. So I can do this any further. I can do this with containers. I can do this with virtual machines. I can do this with VBox managed. I can do this with Vagrant. I can do this even with SSH. I can develop a provider for SSH and start processes on my local machine that just look like a virtual machine, but it's actually done in SSH. So different contexts, basically. So this is really super cool. And I'm very, very proud of Nirvanda that he did this install based on what I've actually delivered. So there was already a lot of stuff developed previously. We wanted to actually showcase this.
Right. So, like I said, so we did that interfacing thing with CMS. That's done. I'll show you some more stuff on CMSD which would come in handy if you're using it. We already looked at CMSD-PS. So I have these containers running. I'll just tell you a bit about this Mongo container. Now, I'm running this on a different host machine in one of my workstations. But if you are inside that workstation, this Mongo container is binding to the host 27017 port. So if you have some sort of a Mongo client like a Roboto, or Windows has a different client for Mongo, you can simply log into this, connect to this port with localhost and the credentials which we passed earlier in the YAML, and simply visualize everything that's in the MongoDB. That's one thing. And then in case you want to stop these containers, what you would need to do is to simply say cmsd-stop. That would stop the CMS as well as the CMS and the Mongo containers. Right. Now, if you go to cmsd-ps, you wouldn't see any Docker containers. And if you want to restart this, it's just a matter of saying again start. That would restart the stopped containers back again, and you would be like it was previously. It would be the same containers. Now let's say in case you would need to delete all the instances and respawn them again, maybe want to recompile the Docker and all of that, then you would, and to let's say if something goes wrong and you want to get a fresh cloud mesh home and all of that, you would need to do cms-clean. That would delete the Mongo container, and it would stop the containers and delete the containers, so you wouldn't have any instances of whatever that's there. But there's a small catch here. Maybe this is only in Unix, that because MongoDB is spawned by a container, Mongo has its own user. So I cannot delete all the DB files from an outside client. So because of that, sometimes you would have some, I call it tombstones of MongoDB. Yeah, that happens in Cassandra most of the time. So if you go here and if you look at the MongoDB, see, these were not deleted properly. So because of this particular reason, you'll have to manually delete it. I'm still trying to figure out if I could do something else, and you need sudo as well because it was created by a different user. So that's like some housekeeping stuff. You'll just keep in mind if need be. And if you guys are like developing on this, I would suggest once you go through the Docker stuff, I would suggest go through the Docker file that has been used to create this CMS containers, because now let's say, I'll give you a good example. Now I wanted to use my fork rather than the Cloud Mesh fork to use this stuff, because now if you are developing on your own fork, you would need to do that. If you have that sort of a requirement, what you would have to do is to remove this clone and use your own clone, like run git clone this particular report, and then build your own CMS container using this particular Docker file. You can do that if need be. If you guys need any help, I can help you out with it as well. Anything else? Yeah, I think that's about it on the Docker CMSD stuff. Yeah. Yeah. If you need anything, just send me an email or whatever I can.
Send him a Piazza post under 2 instructors, because I need to know who's doing what. So as you see, this is a thing that is a little bit ahead of the class, like about 2 months or 1 month ahead of the class. But we posted this because this is an experimental thing at this time, because we wanted to showcase you that you can do this class also without any configuration on your Windows machines. This project demonstrates this, that we can do that kind of stuff. So, I'm very glad that actually Miranda showcased you what you have to do your own development. So you can naturally create your own forks and git clone from your own forks into this container and start developing from there. You can also log into the shell, we have the ---- shell, and do a special git clone from your container in there. Just make sure when you do this, you have to do a pip install -e dot in that directory that you actually clone. That's either done via the Cloud Mesh installer or via a direct
Yeah.
CD and going into this. So fantastic. So I really think I'm very happy about this presentation.
Yeah, I'll show you that just in case. Right. So let's say I log into, yeah, because that will come in handy for you guys. So